So let's get into what these batteries are, a lithium-ion battery. We have an anode and cathode. That's basic electrical theory. The negative electrode of the battery, the fuel side, the copper side that we saw right there, that's where they're putting that paste on there. That paste, that doping material, helps the electrons jump from that side, from the anode over to the cathode. That's how we end up getting the transfer of the energy. And they're going to use the copper on one side, aluminum on the other side, but they're going to end up putting different materials on these to have the jump happen a little bit more effectively, more energy density. Now, of course, to have the lithium ions go from one side to the other, you need an electrolyte. This is batteries, right? This is basic battery. So, let us ask the question, and this is where I ask these simple, dumb, darn questions. Why is a lithium-ion battery so bad? Because. Why is a lithium-ion battery bad? Because of energy density. Why is it a lithium-ion battery bad? Well, because of energy density, because of resistance, and because of electrolytes. Wait, what's going on here? Right. So what is the electrolyte in a lead-acid 12-volt battery in a car? What is the electrolyte? Sulfuric acid. I can't give you another stick. You already have one. But yes, sulfuric acid, right? That's allowing our items to flow right there between the lead panels and everything else like that. So that's a good answer. Don't answer. You may know. You may know. What's the electrolyte in this battery, which is a NiCad battery? What is the electrolyte in a NiCad battery? Anybody? No? Potassium hydroxide. Potassium hydroxide. First question. Sulfuric acid. Is it flammable? No. Sulfuric acid is not flammable. It's corrosive. Does it release hydrogen? Yes. That's flammable and explosive, right? But sulfuric acid itself is not flammable. Potassium hydroxide, not flammable either. It's a caustic material. It can release hydrogen. It can be bad, but it's not flammable. Let's talk a little bit more on that, but I'm going to let an engineer talk and explain that anode, cathode, and electrolyte.
So a lithium-ion battery is made up of 4 major parts: cathode, anode, electrolyte, and separator. You can think of your cathode and anode as your positive and negative terminals of the battery, and you're going to be exchanging lithium back and forth, as well as electrons between these two sides. Now, you have an electrolyte solution, which is facilitating that lithium exchange back and forth, and then you have a separator in the center, which is preventing your cathode and anode from touching so you don't have a short circuit. Okay, so let's get a better understanding of these components, starting with the cathode. Whenever you hear about certain metals being used for battery chemistry, nickel, manganese, cobalt, aluminum, this is generally in reference to the cathode material. And generally speaking, these materials mean the cathode is the most expensive part of the battery, which is the most expensive part of an electric car. Now, there are all kinds of different chemistries which can be and which are used within the automotive industry. And you may hear car makers say things like NMC 622 when talking about the chemistry for their battery. This is discussing the composition of the cathode, in which it is roughly 60% nickel, 20% manganese, and 20% cobalt.
So that gives us a little bit of a heads up on the NMC and all the other stuff. We're going to talk about that here in a second. But we continue. Let's go back to my NiCad battery. And that's what I'm holding right now, is a NiCad battery. We have the potassium hydroxide in there. And I'm going to pass this one out. I want to pass this one out with its twin. We have an LFP battery, LiFePO battery. So you'll notice first the weight's a little bit heavier. And this is where we start getting into the why these batteries are so dangerous. You'll notice the weight, and I want you guys, especially for the firefighters in here, do we have fire investigators in here? Fire investigators, I absolutely want you to take a look at that and start thinking about that. If that plastic is ripped off, will you be able to tell that one's lithium ion, the other one's NiCad? Never, right? And that's one of the difficulties we see, because some may be perfectly fine, some may be really, really bad as we go through that. That NiCad I actually ripped out of a Stryker battery for a power cut. One of our fire station firefighters blew up a battery, not literally blew it up, but it was ripped open. It was like, oh, perfect, lithium ion, oh, NiCad. Ooh, I'm gonna rip this off because they look the same. So it's difficult to identify when we're inside a structure fire for others. But we get back into the why. When I sit there and take a look at this, and we're gonna start going into some videos and some series on this,